Hello and welcome to this video on composing with OpenMusic. Today we won't be doing a tutorial, but we will be looking at a couple of examples. These are some projects that I've done recently or am currently working on that involve the use of some batch editing in OpenMusic. And in one case, I'll be working with CSV files, Excel data. And in the other case, this is a project I'm currently continuing to work on, and it involves some audio editing and analysis. So let's swipe over here and we'll take a look at this patch. This is a patch that I created basically to help me edit a large sample of audio files and then also perform some basic analysis to try and determine, basically the most prevalent pitch content. So the samples that I'm working with are basically English IPA phonemes, and I've got 3 takes of each. And in this case, it includes both consonants and vowels. So to give you just a couple of samples. So I think you get the idea. This is actually really fun to work with some vocalists. Got a couple of samples from about 4 different vocalists, and it's been really interesting to go through and listen to those and begin using these. So actually, let me pull back over here. So the first thing that I realized was if I was going to edit all of these, I felt like it would be more convenient to come up with a better naming scheme. The naming scheme represented here is very descriptive, and it helps me identify the phoneme that they're using. But ultimately, I felt like I needed something numerical so that I could perhaps more efficiently access these files from OpenMusic. So the first thing that I did was I renamed these files, and I'll show you the process. I used an excellent, actually let's go, there we go. This really excellent app for Mac. I'm not sure if it's also available on Windows machines, but in this case, basically what you can do is select these, drop them over. In an ideal world, you could drop them over, let's see, I think it's loading. We'll try one more time. There we go. Yeah, so you can drop these over and then use this sequence item. And in this case, I went with a 3-digit sequence that'll just rename, and then I go back and I do the same thing, but instead use append and make sure to append the .wave string at the end. And so after completing that process, I ended up with this collection of WAV files and was able to kind of get going with using them in OpenMusic. Now, one of the things that was a little difficult about accessing these in OpenMusic ended up being these leading zeros. And so I'd be curious to hear from users who have more experience with this type of batch editing than I do, maybe some techniques that they use. If they, for example, would have gone with the original phoneme characters or something like this 3-digit scheme, or just using 1 and 2 digits where it's appropriate. In this case, I felt like 3 digits would be easier if I needed to be doing any sorts of operations on the strings when I was accessing the file names, so that's why I went with that. But it meant that I had to be creative with this first part of the patch here, everything kind of in this area. So I began with making an arithmetic series to represent the file names that we saw just a moment ago here. So you can see those there. And again, these lack the leading zeros to make them 3-digit strings. So the first thing I did was I used mapcar and this number to string function on lambda mode to convert each of those into a string item. Then used this, and this is converting each of these characters in the string to the ASCII, basically like number index for that character in computer code. And again, I'm not a computer scientist, so I don't know the official terminology or if that's the correct description. But basically, as I understand it, like in this case, 131 can be represented in this scheme by 49, 51, 49. So that was really helpful. I got a list of lists, each of which is representing the string that we see in this previous step. So then I used this OM loop to make sure that I included the leading zeros in cases like these where they were missing. So that's basically all this loop is doing, just checking the length of the list and appending these lists here, where 48 represents the character 0 in this ASCII string convention. So after I had done that, the work of coming up with a way to access these was mostly done. So the last thing I needed was just to add back in the file path, and it was just really easy to do that with this very simple patch here. I probably could have eliminated this and just added that slash actually to the end here. So that's something I'd probably change. In any case, once I had done that, the results, as we'll see, are this convenient list of file paths, allowing me to access each of these files individually. And again, I'd love to hear from more experienced users if there are more elegant ways of doing this. One thing I was curious about too was the use of a file object like this. So I wondered about, for example, going into my original list or my original directory here, and using the terminal to get a list of the file names, saving that as a text file, importing that into OpenMusic, and then attempting to access those file names line by line. So I'd love to know if there are kind of other workarounds for accomplishing a similar thing. But for now, this has seemed to work fairly efficiently, I would say. So one of the first things that I wanted to do was come up with a way of batch editing those 131 files and basically truncating them so that I was only retaining, for example, the transient at the beginning of each of those phonemes. So this truncate patch actually managed to do that fairly efficiently. And in this case, it just creates a path name. So as you'll notice, these path names aren't entirely complete. They're simply strings. So each one of these begins with the quotation mark, ends with the file name, but it lacks the designation that OpenMusic needs to actually turn it into a path, a file path. And it also lacks the .wav file extension that we would need to properly access the sound file. So that's what this OM-MakePathName object is doing. I specify that I'm accessing a directory here. The file path string gets loaded in. The .wav designation is added to the end, and it is translated into a file path. maybe I'll just quick show that for viewers who aren't familiar. So if I just copy this part here and go into this patch, and I'll make a new list, and I'll put that in there instead. Oops, let's see what's wrong. Oh, I bet it needs to be without the parentheses. Let's give this a try. Yeah, I think that's better. Okay. So here we can see this is now a file path. We've got a pound sign or an octothorpe there, and then the uppercase P, and we've added that .wav file extension. So now we can actually load this as a sound file in this sound object here. So let's reconnect this up. Excellent. So I'm able to load these sound files one by one. And then I use this SoX process. This comes from a really handy library, OM-SoX, that I've just gotten to know a little bit over the past maybe couple months or so. I really haven't had time to fully appreciate everything that goes on, but so far it's been very useful. So it has some these two functions, one for processing, one for analyzing. So in this case, process is doing things, like truncating. There's a whole list of different processes that can be applied to sound files, and there's some really helpful documentation that goes through what exactly is involved with these. By the same token, analysis would be used for cases such as I'll show in just a moment, where I'm wanting to detect the pitch. So in this case, I'm using this SoX trim object, and it's hooked up here to this process object. And so basically, it's going through and just trimming down the audio files to save just the first little bit of each. And I've got it hooked up to this map car object, so that all I need to do is select this and evaluate. And as we'll see in the listener here, let's see if this will load. Yeah, it's going through one by one and truncating each of these audio files. It's running slow because I've got my screen capture software as well as Logic and OpenMusic all open at once. But yeah, as you can see, it's basically just going through and trimming each of those files. This is actually pretty slow. When I've done it in the past, it's done it in just a matter of seconds. So I think I'll go ahead and abort this process just for the sake of moving on and saving some CPU time here. In any case, once I was able to truncate those, I had a couple of options then for detecting pitch and trying to determine the most prominent frequencies of these samples. So that's where this patch came in, and it's basically the same setup as this truncate patch, where I'm creating the file path here, loading the sound, and then using SoX. In this case, it's the analysis object, and I'm using this discrete Fourier transform object to produce some analysis data. And in this case, the result of this function is a list of frequencies for each audio file and their corresponding amplitudes. So once I've got those results are loaded in this second patch here that I won't get into just because it doesn't work quite properly quite yet, and it's a little convoluted. But the general idea is to determine the notes of loudest amplitude, and in cases where it's not actually the correct pitch, perhaps due to the fact that the audio sample is a consonant, or if there are some artifacts from the recording process. It's also filtering out those pitches when they happen to be higher than the spoken vocal range of the singer, the soprano that I used to get these recordings. So in cases where it was obviously giving a result that was an overtone of the sound that produced, it wasn't faithful to her actual normal speaking voice, those partials were filtered out. So in most cases, this actually ended up producing results. Like I said, there are 131 of these audio files of phonemes, and it was able to produce results for 105. I'm not sure, I need to go through and actually confirm by ear the number of those 105 results that are correct. And I'll need to do some more revision to this patch to make sure that it's producing correct results for the audio files. But in working through that process, I've created this kind of next section of the patch, which again is creating a path name and loading the corresponding audio file, and then is getting the result from this pitch analysis that you can see over here. And each of these results are just represented in MIDI sense. And so it's just feeding this into a note object. And if I want to check the frequency, I can do that very conveniently as well. So basically, this part just lets me conduct my own assessment orally to ensure that it's producing a correct result. So let's take a listen and see. Yeah, we'll try one more. Yeah, so, on the whole, it's been very helpful. I think in most cases it has produced fairly reasonable results. And as I continue working, I'm hoping to create a more accurate and more effective patch. So that's just one case. I'll quickly show one more that I've found useful. And in this case, I was doing some batch editing on CSV files. And I say batch editing, I was actually able to do it in one sense and not in another, and I'll explain that in a moment. But basically what I was doing here, I think I've maybe alluded to this in a previous video. I was working on a project with some biology students, and they provided a list of 750 of these CSV files, where each one had this scientific taxonomic name associated with it. And in each case, each of these organisms, the CSV file is representing a sequence of numbers that correspond to the probability of genetic mutation. And that's about as much as I know about the science. Mostly I was interested in using that data in OpenMusic to produce pitch and rhythm content. So this was a very similar process as to what I just explained. I created this text file just by going into the directory that they provided and going into that directory in terminal, using the ls command to list the contents of the file, and then save the results as a text file. And so once I had this text file, what I wanted to do is create a way of assigning numbers to each of these original file names. So I went in with name changer, renamed these files as 3-digit integers for the new text files, or CSV files rather. so that I could quickly access the data in OpenMusic. But I also used OpenMusic to come up with this text file which enumerates each of the original CSV files that I was given. So that, for example, they could say, we would like you to come up with data for this CSV file. And all I'd have to do is go in OpenMusic and set it to create the proper data for item 15. And so I was able to do that fairly easily with this patch. And it just basically went through and appended, via this concatenate function, it appended those three-digit numbers to the original CSV file names, so that I had a text file where I could translate back and forth between the three-digit number and the original name of the organism. So once I had done that, I was able to use those in a loop function. And this is similar to other examples that we've seen before. I think I used the same OM loop that I showed in the previous audio file example to add in the leading zeros. And once I had done that, I was able to access those CSV files directly by using this wonderful OpenMusic library. I'll add the link to that. But I was very grateful to the user who contributed that on the OpenMusic Facebook group. It saved me many, many hours of time, which otherwise would have been spent converting CSV files into text files. So that was a huge time saver and allowed me to complete this project much, much more efficiently. So then for the rest of this patch, it's basically taking that data and producing some pitch and rhythm information, as well as some various analyses, looking at interval classes and the number of each interval classes that appear in the pitch material that's produced. So those are just two examples of using OpenMusic to perform some batch processes. I've been so grateful for what little I've been able to do with the software in this regard. It's saved a lot of time. And again, I'd love to know if you have some methods or best practices that you have found for efficiently and easily using batch editing in OpenMusic. So let me know if you've got some ideas or suggestions. Of course, if you have questions, I'd love to do my best to try and answer those. Thank you again for watching, and I look forward to visiting again in the next video.